Okay, here we go. So again, I wanted to talk about topics that would be relevant to this particular assignment. And then I'm recording this so that you can see it if you're doing this assignment later. All right, so on the left side of the screen, I've got a dog class. And I've created some variables, a string for name, a string for breed, and I've created a constructor to initialize those. And I've just added an extra method so that, you know, the dog can speak. Now, I've made a dog over in my tester. And let's say that, so I have a dog named Snoopy. And if I wanted to access its name, I can just say dog.name. And I'll print this, and it should print Snoopy, since that value is stored in the name field. But this is problematic. We don't want people to just change the name of our dog whenever they want to. I mean, they could change the name of the dog directly, and that might be fine. We might be okay with changing the name of the dog, but maybe we're not okay with changing the breed of the dog, since dogs don't change their breed throughout their lives. So we may not want to do that. So that's where we come back to this idea of information hiding and encapsulation. So the concept of encapsulation is that this class should represent all the state and behaviors of a dog. So we've decided to capture the dog's name and breed, and that the dog will speak when we want it to. So state is the data and behavior is the methods. But one concept in encapsulation is information hiding. We don't want people to access our variables whenever they want to. So we mark them as private. And in fact, you must always mark your instance variables as private as part of the AP exam, or you will get those points wrong. You have to know that instance variables are private, at least for the sake of College Board. There are some compelling reasons to not make your variables private in some cases, but not in most cases. So let's say we did want to access the name. That would probably be useful for a client, some client code to do. So what you do is you create public accessors. So we have a string, get name, and that simply returns the name. And we can allow the code to change the name too. I'm just going to get the name, and we'll just double check that it does still print Snoopy. And it's okay that they read the name and read the breed. But we may want somebody to be able to change the name of the dog, but not the breed. So we can control that by allowing somebody to set the name. So we would need to take a new string for the name and then assign it to name. So we can change Lassie's or Snoopy's name to Lassie. Just like that. And now if I print it, it'll print Lassie. All right, so let's talk about how we would create an array of dogs. So creating an array of reference types is just the same as declaring and initializing an array of primitive types. I'm just going to put two dogs in here. And the way it stands right now, there aren't any dogs. We have declared an array for dogs, so it's like a container, like having two dog pens, but there's no dogs in them. And we can prove that quite easily by trying to iterate through and seeing that if we try to say print the name of all the dogs, this should end up in a null pointer exception, right? Because all of the elements in the array are null. Therefore, there's no dog whose name we can get. So we do have to realize that when we create an array of dogs, it's empty, so it has default values of null. But then we can populate it, and the only way to create a dog object is to actually construct one by calling the constructor. Not a bagel, a beagle. And we'll go ahead and put in the second one. And that's a collie. Okay, so now when we run it, it should iterate through both of them. Now it's tedious to handwrite all of this stuff. So that's where reading data from a file really comes in handy. So I'm going to go back here. I'm going to close my dog class for now. I think that's okay. Well, I don't know how to close it from here. We'll leave it open. All right, so we're going to create a text file. So notice how I'm going to put it in my project folder and not in my source code folder. So I'm going to call this dogs.txt, not two dots. And then it's easiest if you say how many dogs you want to create first, and then put all their data after that. So let's stick with 3. So we're going to stick with our Snoopy, who's Beagle, and Lassie, who's a Collie, and Tramp, who is Cocker Spaniel. We'll just go with Spaniel. And I'll save this and figure out how to go back to the dog class. Here we go. All right, so what we're going to do here is we're going to read that file and load it with dog objects. So that's where you're going to need a scanner. Make sure you include your imports. I like to call mine scan, but you can call it whatever you like. And we're going to read from a file. So this is the syntax you will need to read from a file. I'm going to say new file, and then in the constructor for the file object, we're going to type in the name of our file. Make sure you get the right name for it, as well as the right case. So it's case sensitive on file names. All right, so what the error message is that I'm getting now is it's an unhandled exception. So the scanner throws a checked exception called a file not found exception. And while other exceptions aren't checked, this one you have to handle it. So you have basically 2 choices to handle it. You could include a throws clause. Throws file not found exception. And it's imported. So that would fix it. But it will still crash your program if there's the file not found, which is probably not a big deal for a classroom assignment. But you can also wrap this in a try-catch. So a try-catch, and try-catches are not on the AP exam, allows you to call the code and to catch any exception that occurs and to do something to handle it. So in order to finish off the try-catch block, and the try needs a catch, it's possible that a file not found exception is thrown, and then we might just tell it to do, let's see, what is it, print stack trace. Okay, so that'll just tell us all the methods that were called when it does crash. All right, so You could do other things like say the name of, like print out the name of the file that you can find. All right, so that's an option as well. So that error message went away. Anytime you open a file or any kind of resource like this, you should always close it. So if you tell your scanner to, oops, that was not the right thing I wanted. I wanted to grab close. So if you open a resource, you should close it as well. All right, so in the middle, if we remember what our file looks like, it has a number at the top. So we need to read the number, which in our case is just how many. So we're going to read it like that. We're going to create a loop that runs how many times, and we're going to start reading the file. But we have to have somewhere for all these dogs to go. So we're going to create an array of dogs. Kennel, is that how you spell kennel? And we're going to put all the dogs in the kennel. How many spaces do we need? Well, we're going to use the variable how many. All right, so now we can read that file one at a time. So there's two values on every line. The first value is the name of the dog. And there's no spaces in the name, so that's good. We can just call it with next. You can get the breed, not the bred, of the dog also by calling next. Then you can create a dog. And I can create a dog like this and then put it into the array, but it may be easier just to put it into the array directly. So dogs, angle bracket, or square bracket I. Oh, it's not called dogs, it's called kennel. Okay, so, and just to prove that we have some dogs, we can tell them to print all their names. And so for each dog that we get out of the array, we're going to print its name. So we'll run this code again. And we see the three dogs' names that we read from the file, Snoopy, Lassie, and Tramp. All right, so I'm looking down my list of topics that were in this assignment that I wanted to cover. So we talked about making a class, using private for the instance variables. I wanted to show you how to use a for each loop to go through an array. So you can see that example here. And I did want to show you how to use a tab. Now you may already know this, but in case you forgot, we have special characters called escape sequences that allow us to put things like tabs, new spaces, or I'm sorry, new lines, and quotation marks and backslashes. Those are called escape sequences, and so this is the one for tab. So now that I run this, we should see the name of the dog, then it's tabbed over to do the breed of the dog. Now you can see that the spaniel didn't line up exactly, and that has to do with the tab stops. So using tabs not perfect, which is okay for this assignment, the batting average. Now if you know how to format using printf, you're welcome to do that. All right, the last topic that I wanted to cover, and I just may make an extra file for that. Let me just grab my tester here. Where is it? Does it show up? Well, we'll just use this one. I wanted to remind you when you're working with averages, so let's say that we're trying to decide how many fleas on average there are on a cat. We have 10 fleas and we have 3 cats. And so we would say, well, you know, there's 3 1/3 flea on a cat. And so we usually want our averages in terms of doubles. And we know that we have to divide how many of something there are by how many, you know, things. So we divide fleas by cats. So if we were to print this, let's print average. And I'm just going to comment all the stuff down here so it doesn't cause us problems. So if I run this code, we're hoping that 3.33333 shows up, but that's not what we get. So I know this is first year material, but it is so easy to forget when you're creating an average that you really want real division, which means that one of the operands has to be a double, so you don't get one of the operands has to be a double so you don't get integer division. So when we're really expecting the value to be 3.33333, then we want to guarantee that it's real division. All right, the other thing I wanted to talk about was rounding. So we are able to round, let's say that there's 1,000 fleas, a bigger number. And so these poor cats, these poor flea-ridden cats. So let's say we want to round this number. So we want to use math.round. And let's say we want to store it in an integer. So average int. So we don't want to cast because we would want it to round up if it was higher than 0.5, right? So we want to use round, and there is a math function called round. And we're going to pass our average in on that. But this won't compile. So you may come across this when you're writing your code. And you're thinking, well, what's wrong? I'm rounding, it's chopping off the decimal or rounding the decimal. What's the deal? Well, the round method itself actually returns a long. A long is an integer type. That's here, you can look at the message. It required that I assign an int value to an int variable, but I'm giving it a long. And the math class's round method returns a long. A long is an integer that's twice as many bits. So an int is 32 bits and a long is 64 bits. And so this has to be adjusted. One option is to store it in a long, totally fine. Another option is to cast. The reason why you have to do explicit cast is because the Java designers don't want you to ruin your data by reducing the size of your integer value. All right. If for some reason you wanted to store this as a string, then you don't really have to do a cast. And you can simply do it like that. So let's go ahead and print out what we got just to see what we get. So I just wanted to give you options on that in case you haven't seen that before. All right.